Question 4. Circles. Circles question. Well, as soon as you see the equation of a circle, I tend to just put down the centre and the radius straight away, but that's what it wants anyway, centre and radius. So centre, but there's two circles, I'll call this centre 1. I tend to position it just under the two terms responsible for the centre there, so it'll be the half there being doubled, so it'll be half of those, so -4, -2. Radius, that'll be the square root of those numbers squared, 16 plus 4, take away the number n, which is negative, so plus 38, so that's going to be 2058. That's the first bit. That was easy enough. What's next? Another circle. Another circle, here's its equation. Find the distance between the centres, so what's the centre of the second equation? So part B. Second circle, x minus 4, so it's a 4, y minus 6, so it's a 6. Radius squared is at the end, so straight away radius root 26. Didn't actually ask for them specifically, but I'm going to see you need it in the next bit. Find the distance between the centres of these two circles. Well, that'll be C1, C2, and then show that they intersect. Well, C1, C2, I'll just square it out to save the big square roots, would just be the difference in the x coordinate squared, difference in the y coordinate squared. So it'd be 4, take away -4, so it'll be 4 plus 4 squared. 6, take away -2, so plus 2 squared. So that's 8 squared plus 8 squared. So that's going to be, you know straight away it's going to be, the answer is going to be 8 root 2. I'll just go through it. So it's 64 plus 64, which is 128. So C1, C2 is going to be root 128, which does simplify down, but looking ahead to this question, I don't know how much use that will actually be, because it just wants to show that these circles intersect. So maybe I'll just leave it in that form just now. So intersect, well, that all depends on the size of the radius, of the radii, and they're all awkward numbers. Because the situation would be, if two circles were touching, then the distance between the centres would have to be the same as the sums of the radii. If they intersected, the distance between the centres would have to be less than the sum of the radii. And if they actually touched inside, then the distance between the centres would be the difference between the two radii. So here if it says show the intersect, that means you have to show that the distance between the centres isn't big enough for the radiuses or the radii to stay separate. So that means I need to compare that with the sum of these two. But these won't add easily because they don't reduce to the same fraction. So that means I'll have to resort to decimals here then. That's a bit of a paste. So I've got root 58, I've got root 26, and I've got root 128. I just need them as decimals to check that that works that way. So that's working them out, which I already had. I had the square root of 128 is 11.3. The square root of 58 is 7.6, and the square root of 26 is 5.1. Well, 11.3, that comes to 12, that comes to 11. So I can state from that root 128 is less than the square root of 58 plus 26, which means that the circles intersect. And notice you can't just add them. The square root of 58 and the square root of 26 is not the square root of 84. Because then you would think, oh, 128's bigger than that, so that pushes them apart. It doesn't work that way at all. You have to work them out separately. I would have expected that question to have them reducing so they're all multiples of root 2 or root 3 or root 4, so you can compare them directly without resorting to this. But there, the circles intersect because the distance between the centres is less than the sum of the radii. Maybe I should have stated that in words, but I didn't. So to part C. The line with this equation is a common chord passing through the points of intersections of the two circles. Well, that's the only place you could get a common chord. So what does that look like? Not that you necessarily need it, but that's negative, that's positive for the centres, but that's smaller. So there's a small circle up here, and there's a larger circle down there. They intersect here, so the only common chord they've got is this one. So you have this common chord, that being the line y equals 4 minus x. Right, find the coordinates of the point of intersection of the two circles. Well, that's the same as saying find the point of intersection of the line with either of the circles. So it's just a case of which one do you prefer. Which of these will I substitute that into? Well, I'll call that 1, just so I can name it, and then I'll give these names like 2 and 3, just so I don't have to write them all out when I make my reference. Well, if I substitute it into this one, I'm going to have 2 squares to expand out. If I substitute it into this one, there'll only be 1, so I'll put it into that. So I'll just say substitute 1 in equation 2, although maybe it should be 1, 2 and 3. So I'm going to rewrite the first equation, only whenever I see y, I write 4 minus x. So I'm going to have x squared plus, instead of y, 4 minus x, plus 8x plus 4 times, instead of y, 4 minus x, minus 38 equals 0. And that's just going to be a quadratic. So I'll multiply that lot out. X squared plus, square a bracket, square the first, twice the product, square the last, plus 8x. Multiply the bracket, plus 16, minus 4x, minus 38, whoops, sorry, circle, equals 0. Then that's just going to reduce to a quadratic. There's only 3 different types of terms. So gathering them up, I've got 2x squareds, minus 8 plus 8, well that's very handy, minus 4x. And then for the numbers, I've got 16, 16, that's 32 minus 6, equals 0. Handily as well, there's a nice wee common factor to save me doing a nasty factorisation. That leaves x squared minus 2x minus 3 equals 0, which means that's just going to be very simply x times x, 1 times 3, the negative goes to the larger, opposite signs equals 0. So that means that x equals negative 1 or x equals 3. Now you've just got to find the y coordinates. All 3 intersect there, you could put them into any of them, but obviously that's the choice there to find it. So you're just going to substitute them into 1. So using 1, you've got this. If x equals negative 1, y is going to be 4, take away negative 1, which is going to be 5. For this one, if x is 3, y is going to be 4, take away 3, which is 1. So the 2 points of intersection are going to be in order negative 1, 5, and 3, 1. And that's that question done. And so question 5. Right, what's this? Trig equation, significantly a double angle equation. One angle is double the other angles. So I'll be using that formula. What's it just say? Find the values, obviously. One thing to spot straight away, 360 will not be included amongst the solutions because it says less than that, and neither I've not written them in. The degree signs were there, even though that confirms it. So this is in degrees, at least that's handier. Right, so cos 2x can be changed into either sine squares or cos squares. Because this says sine, then I'll change it into sine squares. Not because of this. If that had said cos, then I'd have changed it into cos squareds, because I know that that sine squared, if I required, could be written as 1 minus cos squared. That can go either way. No, it's this one I need to match. So instead of cos 2x, I'm going to write 1 minus 2 sine squared x plus the 2 sine x equals sine squared x. And then I think I'll just write that all the other way around. Take it all over to this side rather than have negatives. Have that if you like, and then change it, flip all the signs over. So bringing that over, I would have, by writing it on this side, 3 sine squared x, because the minus 2 comes over as plus 2, minus the 2 sine x, and then minus the 1, equals 0. And then that's a quadratic. It's a quadratic in sine. Don't think I've left enough room there for the signs to go in now. Just the same as if it said 3x squared minus 2x minus 1. Just instead of x's, it's going to be sines. Put them in straight away. And it's just a case of figuring out what it needs to be. Well, it's a 3. So it'll be 3 and 1. And it's a 1. So it'll be 1 and 1. There's a negative in the middle. That'll go to the bigger product. That's one on the outside. It's a negative at the end, so they must be opposites. And then you solve them independently. So if that bracket is responsible for the product being 0, then that bracket would equal 0, which means the contents of it would be the 3 sine x would equal negative 1, dividing by the 3, so that's negative a third. Well, there'll be 2 answers from that. Or if this was the bracket, if this was the part of the product responsible for 0, then that part would equal 0, in which case sine x would just equal 1. you think of the graph for that part. So the two answers would be, for this part, sine of x is negative a third. Right, well, I suppose you could just put that down at the side if we're just going to resort to the all sine tan cos. It's negative, so it's going to be down below. So it's just a case of finding the acute angle. So you do inverse sine of a third. I've already taken care of the negatives by putting the angle positions in the negative places for sine. So that'll just be shift sine of 1 divided by 3. That gives me an acute angle of 19.47, call that 19.5. So it's 19.5 in either of those positions. So it'll be 180 plus 19.5, and all the way around will be 360 minus 19.5. So that means x will be the 180 plus it, 199.5, or the 360 minus 340.5. Sin x equals 1, not going to get it from that graph, from that table, just going to use the graph. The sine graph looks like this. Only gets to 1 once, that was at 90. X equals 90. And then just put them into order. So the solution would be 90 degrees, 199.5 degrees, and 340.5 degrees, and that's that one done. Number 6, optimisation question. Find the maximum area, because as you move this point Q about, the size of that rectangle changes from down here a long thin one, squaring out and then becoming tall and thin. You can always see, because it's going to go from 0 to 0, there's going to be a maximum area somewhere in the middle here. Anyway, what does it say? Show first of all that QR equals 6 minus 2t. Well, the first thing you should notice here is, I'll put in that wee right angle sign just to emphasise this, and a wee right angle sign, and a wee right angle sign. You've got similar triangles. There are 3 similar triangles here because they are all right angle triangles with the same angle. You've got the big one that goes from the 3 to the 6, that side's 3, 6, that side's 3. You've got this little small one here, which is similar to this one because it's got a right angle, so it just needs one more the same, and they share that, so that's obviously the same. And we've got this one up here, which I don't think I'm going to need because I know the length of that side already, and I don't not ask for any other size in it. And this one, I know this side, or I know an expression for it. It's 3 altogether to here. It's t up to here, so that part is the difference between 3 and t, so that's 3 minus t. And it says, what's the length of QR, which is this side, QR. Similar triangles. If triangles are similar, then one is a fraction of the other. Corresponding sides make the same fraction. Corresponding sides are in the same ratio, which means that for this one, the length of QR, which is what I want, so I'll put that down first, QR over its corresponding side, 6, will be the same as, in the same order, any other side, that's the 3 minus t, over its corresponding side, 3. So straight away, take the 6 across and multiply. 6 times 3 minus t over 3, that cancels down to 2. 2 times it, I'll put it all out. 2 times it, 6 minus 2t. QR equals 6 minus 2t. So that's the first bit. Now what's the next part of it? Part B. Take the lid off of that. So for part B, find the coordinates of Q. Where would you move that point Q to? By changing these rectangles to get the biggest rectangle. Well, I need an expression for that. It doesn't give me an expression for that. I need an expression to optimise. Well, it's a rectangle, so that means the area of it. So that area that they're talking about would be the length times the breadth. Length times breadth. The length is t. The breadth you just got was 6 minus 2t. So actually the expression is really simple. 6t minus 2t squared. You have to find the biggest value of that. That's just an upside down parabola. You know where it's going to happen. You can almost just factorise that in your head, take out the 2t, and you're going to have what? 3 minus t. 0 and 3 halfway, 1.5. Anyway, I'll go through it. So, standard procedure would be, that's right, to optimise that, differentiate it. dA by dt would be 6 minus 4t. If it does have an optimum value, then that would have to happen wherever it stopped either rising or falling. If it just kept increasing forever, there'd be no optimum. If it just kept falling forever, there'd be no optimum. There would be maximum and minimums in an interval. but they don't put optimum value overall. It's only going to happen if it ever stops. So optimum value would be found by equating the derivative to 0, which means that 6 minus 4t has to equal 0, so 4t has to equal 6, and no surprise, t is going to be 6 upon 4, 3 upon 2, which is 1.5. I'll just leave it as 3 upon 2. So that's the first bit of it. Find the coordinates of Q for maximum area. Maybe you should just take the time out just to demonstrate it is the maximum area. You could use the second derivative. I'll just go with this one. So I've got 3 upon 2 for t, and I want to just check what happens to dA by dt at these values. Something before it, something after it, not something too far before or too far after, because there are limits to this question. That line cut at 3. T can't exceed 3, nor it can get less than 0. So just try it at 1 and 2, for instance, something like that. So that for that derivative, you would have had that would be 0. Before it was a positive value. Work out 2 was a negative value. Okay, cheating a bit. I know it's a maximum because I know I've got an upside down parabola with that expression. So there's a maximum here. So I can say this. I've got the maximum area, and it doesn't ask for that, does it? No. It just says there's a maximum area when t equals 3 upon 2. Then, coordinates, that means you need to know the y coordinates. Well, I already worked out that. The y coordinate of Q is that QR, which is 6 minus 2t. The x coordinate is t, because that's the distance along until you reach it. So that means I can put down this. The x coordinate is 3 upon 2. The y coordinate will be QR, which is 6 minus 2 times that. 6 minus 2 times 3 upon 2. 6 minus 3, which is 3. So that Q must be the point. 3 upon 2, 3. And so to question 7, the last one in paper 2 and the end of that particular exam. Find the shaded area lying between these two lines. Sometimes this causes a great deal of confusion because you're not sure where things start and where things finish. Maybe you see these 4 different intersecting points and think what you meant to do because you're just used to seeing 2 of them, for instance. Well, it's just that this is going to be a combination of 2 separate ones. Now you could do all sorts of things, like start dividing it into boxes, a wee bit down here, a box below, and so on. But all areas, there's an area that's up here. All areas are worked out using integral as areas between curves. There's always a top, there's always a bottom. Even when you do a simple one, and it says what's the area from here, going from what's the area between negative 1 and 3, you're still doing a top and a bottom. There has to be a bottom curve, or else it would just go on forever. It's just in all of these, when you work out the integral, it's going to be whatever that is minus y equals 0. You just don't bother writing it in. There's always a top and a bottom. So there, for this one, this is going to be made up of, because these are both straight lines, there must be 2 separate areas that you're going to have to find and then work out the difference between them. You should be able to spot it straight away. That would be a nice simple top and bottom. Top, bottom, if it was the whole lot. So what's wrong with it? There's a bit missing. Well, just work out the area of that missing bit. Those are the 2 parts. You've got the whole area, and you're going to take away the little top part. This area, take away that area. Area 1, area 2. Still means you have to find these 4 intersections to know where to start and stop for each of them. So, for those, first one, you've got y equals this. I want to find these limits here. So that I've got, if y is 24, then I've got 32 minus 2x squared equals 24. Rearranging that, I'll bring that over. 2x squared equals 8. X squared equals 4. X equals plus or minus 2. So that's going to give me the limits for the top one. It goes from negative 2 to 2. This is a parabola. Parabolas are symmetrical. If it had been a cubic one, I wouldn't have been quite so safe in saying the 2 halves are the same. This is a parabola, so I don't need to go from negative 2 to 2. I can just do that half and double it. Right, what about this one here? Next one, 32 minus 2x squared, I want to equal 14. Well, that means that 2x squared is going to have to equal 18. So x squared is 9. So x is plus or minus 3. So that's the limits from this. So the big one's going from negative 3 to 3. The small one's going, the top part of the double one's going from negative 2 to 2. but you don't need to do that. We'll just do the halves and then double the answer. So now it's just a case of setting it all out. So the big area, the whole area, so we'll call that area 1. So area 1 would be going from -3 to 3 of the top minus the line y equals 14, but since it's symmetrical, I'm just going to double going from 0 to 3 of the top, take away that. So the top curve being the 32 minus 2x squared minus the bottom one being the 14, all of that dx. So it's 2 times the integral, just to sort that out, although we had that before, so that's going to be taking that part away is 18 minus 2x squared dx. There's another 2 I could have taken out, but I've written it now. So it's going to be 2 times, and that'll go to 18x minus up to 3 divided by 3, 2/3 of x cubed, going from 0 to 3. Working it out, well, it'll be 18 3's, take away 2/3 of 3 cubed, minus, they're both zeros. So that's going to be 2 times 18 3's, take away that, well, you can just work that all out on your calculator, I suppose. That's 54 minus, and that'll be 3 knocks out one of the powers, makes it 9, 2 9's are 18, and then that's going to be 2 times 100, so that's going to be 72, I don't know where the 100 came from, units squared, for the first bit. Yeah, that's it cleared, transfer the information. So the big area, the whole thing, top take away bottom, was 72. But I don't want the whole thing, there's this missing part, so work out the missing part now. So this is going from -2 to 2, but again it's a parabola, it's symmetrical. So area 2 is going to be double the integral, just from 0 to 2 of the top, take away the bottom. I'll write it all out, even though I had a similar expression down earlier. Minus 2x squared minus, this time it's 24 up there, dx. So it's 2 times the integral from 0 to 2 of 24 of these, 8 minus 2x squared dx. So it's going to be 2 times 8x up to 3 and then divide by 3 from 0 to 2. Now it's just a case of working that all out. Again, there's a 0, that's why it was handy being symmetrical. So I've got 8 times 2 minus 2/3 of 2 cubed, not so good as last time, minus another part's just going to be 0, because it's only x's and it's a 0 that's going in. So I've got 2 times, this time that's going to be 16, take away, and that's going to be 8, 16 upon 3. Well, that's quite handy, because I've got 16 take away 1/3, so that must be 2/3 of 16. So now I've got 4/3 of 16 for this part here. So 4/3 of 16 must be 64 upon 3. Or I could write that as 21 1/3 square units. So this part was 21 1/3 square units. Right, last part, I've just used the whole board again. The final area would be the difference between these two. Oh, can I just put it down here? So the area you actually want would be 72 take away 21, so that's almost 50, 50 and 2/3. 50 and 2/3, can I just put that? Just cheat, as if I'd had that down in advance. 50 and 2/3 square units. Double checking, of course, that there were no scales mentioned here. Sometimes they do that and they say each unit in the diagram is something like 5 square meters, but it wasn't, so it's just units. 50 and 2/3 square units. Done.